Hello dear students, welcome back to my lesson. On today's video, we are going to talk about the rotational kinetic energy. So before we get started a new lesson, I would like to remind you something about the previous lesson. If you remember, in a previous lesson, we talked about the rotational kinetic energy. The rotational kinetic energy is the energy of an object due to its rotational motion and measured in joule. So the rotational kinetic energy depends on the moment of inertia and angular, the square of angular speed. For example, when a solid sphere is rolling at some inclined surface, in that case, when the incline is a rough surface, okay, when the when the bowling ball is not skidding or slipping, in that case, the object is rotating. The bowling ball tries to rotating and its position continuously changing. So at the end of the incline or at the bottom of the incline, all the potential energy of the bowling ball is converted to total kinetic energy. Why? Because in that case, when the bowling ball is releasing from some incline, from some height of the incline, in that case, the position of the bowling ball continuously changing and also it is rotating. So that is why it has both types of kinetic energy, rotational kinetic energy and translational kinetic energy. Okay. So today's lesson, we are going to solve some questions that related with the rotational kinetic energy, and I'm going to prove some ratios between the rotational kinetic energy, translational kinetic energy, and total kinetic energy. If you look, the ratio of translational kinetic energy to rotational kinetic energy, okay, for this shape, for example, for the ring is equal to 1/1, okay? For the solid disc is equal to 2/1. The ratio of translation kinetic energy to rotational kinetic energy for the solid cylinder is equal to 2/1. The ratio of translational kinetic energy to rotational kinetic energy for the hollow sphere is equal to 3/2. Okay? Now, I'm going to prove this ratio. Okay? Why the ratio of translation kinetic energy to rotational kinetic energy for the hollow sphere is equal to 3/2. We have to find the ratio of kinetic energy from translation to rotation. For what? For is equal to 3/2. This is for hollow sphere. Okay? This is for hollow sphere. We have to start from here. Translation kinetic energy is equal to what? 1/2 mv squared. This is translational kinetic energy is always equal to 1/2 mv squared for every shape. What about rotational kinetic energy? Rotational kinetic energy is equal to 1/2 I omega squared. The moment of inertia times angular speed square. Moment of inertia for what? For hollow sphere. Okay? Is equal to, write down the translation kinetic energy, the same, okay? And 1/2 times. And instead of moment of inertia for the hollow sphere is equal to what? Is equal to 2/3 mr squared. Be careful. The student must keep in mind that the moment of inertia for the hollow sphere we studied is equal to 2/3 mr squared. This is for hollow sphere. For the solid sphere is equal to 2/5 mr squared. Okay. Now, times omega squared is equal to what? Omega is equal to V/R. What about omega squared? V squared over R squared. V squared over R squared. R with R cancel. What is remain? 1/2 in numerator. So in denominator, 1 times 2 is equal to 2/6 mv squared. Why? Because R with R cancel. What is remain? Only m and v squared. Okay? According math basic, we have to rearrange this equation. Okay? 1/2 mv squared, stay here, times, if we take this term into from the denominator into the numerator, according math basic, this ratio becomes flips. Okay? It becomes 6/2 mv sorry, MV with MV cancel, okay? We have to, sorry, MV with MV cancel. What does remain? 1 over 2 times 6 over 2. 1 times 6 is 6, 2 times 2 is 4, 4.6. So you can simplify this term. Divided by 2, 6 divided by 2, 3, 4 divided by 2, 2. Finally, we got this number, translation kinetic energy. The ratio of translation kinetic energy to rotational kinetic energy for the hollow sphere is equal to 3 over what? 3 over 2. Okay? And also, if you change the ratio of rotational kinetic energy to translational kinetic energy, just flip this ratio. It becomes 2 over 3. It's very easy, okay? But please pay attention for the moment of inertia for each shape, okay? This is just for reminding you the moment of inertia for the different shape is equal to, for example, for thin hoop, 1, solid disc 1 over 2, hollow sphere 2 over 3, and solid sphere 2 over 5. So this table is very important, guys. Be careful, please. This is the ratio of translation to total for the ring hoop, wheel, bicycle tire, and this is rotation for total is equal to 1 over 2. Okay. The total kinetic energy for wheel is equal to mv squared, but for the hollow sphere is equal to 5 over 6 mv squared. So the v final also you can prove the final velocity for each shape when it's releasing from the incline. Okay. Look. This is total kinetic energy for disc. Okay. Y total kinetic energy for disc is equal to 3 over 4 mv squared. Now I'm going to prove this equation. This is total kinetic energy is equal to 3 over 4 mv squared. For what? For disc. Okay, how can we get this equation or this value? Total kinetic energy, as you learned, is equal to what? Is equal to the sum of translational kinetic energy and rotational kinetic energy. Bring down this total. Translational kinetic energy is equal to what? 1 over 2 mv squared. What about rotation? 1 over 2 I omega squared. Okay? I omega squared. Bring down this total kinetic energy. Write down mv squared. So, plus 1 over 2. But instead of this I, because our shape is disc, so that is why you have to write down what? 1 over 2 m r squared. Why? Because the moment of inertia for disc is equal to 1 over 2 m r squared. And times omega squared is equal to v squared over r squared. R with r cancel. What does remain? Total kinetic energy for disc is equal to 1 over 2 mv squared plus 1 over 2 times 1 over 2, 1 over 4 mv squared. Why? Because r with r cancel. 1 over 2 plus 1 over 4, because they have the same term. Okay, 1 over 2 plus 1 over 4 is equal to the lowest common factor between 2 and 4 is 4. 4 divided by 2, 2, 1, 2 times 1, 2 plus 1 times 1, 1 is equal to 3 over 4. So the ratio, the total kinetic energy for this is equal to what? 3 over 4 mv squared. So you can add these two terms because they have the same variables. Okay? Is equal to what? 3 over 4 mv squared. I hope you understood well. And look at this question. Very good question, please. Listen carefully. The question says, when 0.5 kilogram pulley with the radius, it is shaped as a disc, okay? It is radius r. R is equal to 0.1 meter, okay? rolls without slipping down on an incline, how much kinetic energy does it have when its center of mass moves 1 meter per second square? So it is mass 0.5 kilogram. So it is moving with a velocity 1 meter per second. How much total kinetic energy, sorry, there is a mistake here, please correct this mistake. How much total kinetic energy does it have when its center of mass moves at 1 meter per second? Please correct this mistake. Okay, just add the total kinetic energy. What is unknown? Total kinetic energy for the DC. Okay, so in that case, the total kinetic energy, also you can write, solve like that. Total kinetic energy is equal to 1 over 2mv squared plus 1 over 2I omega squared. Okay, because we don't have I and omega. Okay, but we can find it. I for the pulley is equal to what? 1 over 2 mr squared. 1 over 2 times 0.5 times 0.1 square is equal to what? Is equal to 0.025 kilogram meter squared. This is I. So what about the omega? Okay. Omega is equal to what? V over R. 1 over 0.1 is equal to 10 radian per second. Okay? So now replace into this equation to find the total kinetic energy. Total kinetic energy is equal to 1 over 2 times 0.5 times 1 square plus 1 over 2 times I. We found it 0.025 times 10 square. Total kinetic energy is equal to what? Is equal to 0.375 joule. In this way, you can find the total kinetic energy. And also in a fast way, you can also find the total kinetic energy, which is equal to 3 over 4 mv squared. Total kinetic energy is equal to 3 over 4 times 0.5 times 1 square, which is equal to 0.375 joule. Okay? In this way, you can find the total kinetic energy. This is for pulley. It is shaped as a disc. And also, you can find the total kinetic energy for the solid sphere, for the ring, and for the hollow sphere. Question 28. Look at this question. Very good question, guys. Please pay attention for this question. Ice skaters use the conservation of angular momentum. Ice skaters use the conservation of what? Angular momentum. What do you mean by ice skaters use the conservation of angular momentum? It means that for the ice skaters, when extended his hands or feet away from his body, in that case, what happened to the moment of inertia? Increases. Why? Because the radius, the distribution of mass around his body decreases. His body decreases. In that case, when the moment of inertia increases, what happened to the angular speed? Decrease. But it is angular momentum is constant. But in the case when close hands to his body or her body, in that case, the radius decreases and moment of inertia decreases. So it is angular speed must be decreased to remain the unchanging of the angular momentum. Okay, the angular momentum is conserved for the ice skaters when the net torque is 0 that acting on the skaters. Okay, so ice skaters use the conservation of angular momentum to produce high speed spins when they bring their arms close to the rotation axis. Imagine that a skater moves her arms inward. Okay, so in that case, what happened to the R? Decrease. Moment of inertia? Decrease. But angular speed? Increase. L constant. Okay, so when cutting the moment of inertia in half and therefore doubling the angular speed, if we consider the rotational kinetic energy, we see that the energy is doubled. Because the ice skater is using the conservation of angular momentum, as I told you, rotational kinetic energy is equal to 1 over 2 L omega. When does rotational kinetic energy is equal to 1 over 2 L omega? When the angular momentum is conserved, when L is constant. When does rotation kinetic energy is equal to 1 over 2 L omega without square? When the angular momentum is conserved. Now, what is the relation between rotational kinetic energy and angular speed? It's directly proportional. Okay? So, because the moment of inertia is cut into half, cutting moment of inertia in half, so it is therefore doubling what? Angular speed. When the angular speed is doubling, what happened to the rotational kinetic energy? Increases by factor 2 or 4? Absolutely changes by factor of 2. Also, the rotational kinetic energy becomes doubling. Why? Because the skaters uses the conservation of angular momentum. Thus, the angular momentum is conserved, the kinetic energy is not. So, the kinetic energy is doubled in this situation. Angular momentum is conserved, but kinetic energy is not conserved. Where does this extra rotational kinetic energy come from? The answer is, as the skater pulls his arms toward or close his body, he does work. Okay? So, in that case, the work which is then converted into rotational kinetic energy. Okay? So in that case, the work is converted to what? Rotational kinetic energy. Okay? In the case of extended the hands away from his body or her body, in that case, the rotational kinetic energy is converted to the work done. The work is done. Okay? So this work that done by the student or by the skaters, in the case of bring his hands close to his body, in that case, the work done is converted to the rotational kinetic energy, so that is why it is rotational kinetic energy increases with the same factor of angular speed. Okay? Why? Because the work is converted to what? Rotational kinetic energy. But when the skater extended his arms, in that case, rotational kinetic energy is converted to work. Okay? Look at this note. If the angular momentum is conserved, both moment of inertia and angular speed must be changed together. Okay? When does moment of inertia and angular speed change together? If the angular momentum is what? Is conserved. If the angular momentum is what? Conserved. Okay? So, write down here, in that case, rotational kinetic energy is equal to 1 over 2 L omega without square. Why? Because the angular momentum is conserved. But if the angular momentum is not conserved, the angular speed changes, but its moment of inertia doesn't change. Like a rigid body, like merry-go, like a sailing fan. For the sailing fan, if you try to increase its angular speed, its moment of inertia changes during rotating? Absolutely no. Why? Because the sailing fan is a rigid body. Its moment of inertia doesn't change by changing its angular speed. When the angular speed changes, angular momentum also changes. Why? Because moment of inertia is constant. So in that case, kinetic energy rotation is equal to 1 over 2 I omega square. Look, here for the conservation of angular momentum, rotational kinetic energy is directly proportional to the angular speed without square. But when the angular momentum is not conserved, rotational kinetic energy is directly proportional to the square of the angular speed. What do you mean by that? It means that if the ceiling fan's angular speed changes or increasing by factor of 2, or it is angular speed doubling, becomes double. If the angular speed of the ceiling fan becomes double, what happens to the rotational kinetic energy? It is rotational kinetic energy becomes quadrupled. Why? Because rotational kinetic energy for the rigid body who they don't have a conservation of angular momentum, so that is why the rotational kinetic energy becomes quadrupled. Okay, so this is very important. Please pay attention. Okay, and also I mentioned here rotational kinetic for rigid body for the skaters. What do I mean by for rigid body? It means that the radius doesn't change. Mass already constant. Moment of inertia is constant for rigid body for the ceiling fan. Okay? So when the ceiling fan is rotating, it is moment of inertia doesn't change. It is radius doesn't change. But angular speed may be changed. When angular speed increase, what happened? Angular momentum also increase. When angular speed decrease, it is angular momentum also decrease. Okay? L is not conserved, it changes. So that is why rotational kinetic energy is directly proportional to the square of angular speed. But for the skaters, what do you mean by the skaters? It means that during rotating, it is radius changes. When the radius changes, distribution of mass, also the moment of inertia changes by changing radius. But mass, in both cases, is constant, and angular speed changes. Angular speed and moment of inertia, both of them changes together, but it is angular momentum stay unchanged. So in that case, rotational kinetic energy is directly proportional to the angular speed without square, but here with a square. Okay? Question 32, very good question. Two spheres look identical. We have two spheres with the same mass, same shape, same radius, same color, okay? Same mass, one is hollow and the other is solid. When we say they have the same shape, it means that the outside shape, its color is the same, okay? But actually these two spheres are different. One of the sphere is hollow sphere, one of them is solid, okay? The hollow sphere, it is inside the object, it's empty, there is no mass, okay? Which method would determine which is which? How can you determine which object, which sphere is hollow sphere and which sphere is solid sphere? By scaling on the balance? No, because they have the same mass. Okay? A. Roll them down and incline? Yes, of course. Drop them the same height? No. Because by dropping them, in that case, both of them reaches with the same acceleration, which is the free fall acceleration. Weigh them on scale? No. So the best way to determine which is which, you have to roll them down and incline. If you roll them down and incline, assume that this is the solid sphere and this is the hollow sphere, okay? So which one reaches the bottom of the incline? Absolutely the solid sphere. Okay, this is solid sphere and this is hollow sphere. In this way, you can determine which is which. Okay, the faster ball is a solid sphere, and the ball that came after the solid sphere is a hollow sphere. So the best way, we have to roll them down and incline. A rough incline, not a smooth incline. Prove that the translation velocity of the center of mass for a solid sphere is equal to 10 over 7 gh. Okay, now I'm going to prove this. Y final velocity at the bottom of the incline. Look, this is rough surface. Okay, this is solid sphere. What is this? Assume that this is solid spheres. Okay, if you roll down the solid sphere, it is velocity at the bottom of the incline is equal to what? Is equal to 10 v final at this point is equal to radical 10 over 7 gh. What does the final velocity of the object at the bottom of the incline depend on? It depends on the height and its shape. Now I'm going to prove this value. How did we get this value? Okay. At first, which type of energy do we have? Gravitational potential energy. But when the bowling ball is rotating downward, this gravitational potential energy is converted to what? Total kinetic energy. Why total? Because we have both types of energy, kinetic energy. Translational kinetic energy and rotational kinetic energy. Okay? Translational kinetic energy, because its position continuously changes, and rotational kinetic energy because the solid sphere is rotating around itself. So in that case, according to the conservation of energy, gravitational potential energy is converted to what? Total kinetic energy. Okay? Gravitational potential energy is equal to, gravitational potential energy is equal to mgh, and total kinetic energy is equal to 1 over 2 mv squared plus 1 over 2 I omega squared. This is total kinetic energy. Okay. Now bring down this mgh, 1 over 2 mv squared plus 1 over 2. I for the solid sphere is equal to what? Moment of inertia for solid sphere is equal to 2 over 5 mr squared. And omega is equal to v over r squared. It becomes v squared over r squared. And instead of this I, write down what? 2 over 5. Why? Because our shape is solid sphere. What is our shape? Solid sphere. Okay? 2 over 5 mr squared times v squared over r squared. R with r cancel. What is remain? mv squared. mgh 1 over 2 mv squared. 1 times 2, 2. 2 times 5, 10 mv squared. M with m cancel. Okay? So in that case, gh is equal to what? 1 over 2 plus 2 over 10. 1 over 2 plus 2 over 10. Math basic is equal to 10 lowest common factor. 10 divided by 2, 5. 1. 5 plus 2, which is equal to what? 7 over 10. GH is equal to what? 7 over 10 V squared. Okay? So, by rearranging this two equation, V squared is equal to what? 10 over 7 GH. Take the square root to remove the square. It becomes what? 10 over 7 GH. This is final velocity for the solid sphere when it reaches at the bottom of the incline. It is very important, and also you can memorize this value, but I suggest for you to prove one by one. This is for solid sphere, and this is for the hollow sphere. For the ring and for the disc is the same, only the value changes. Okay? So according to its shapes, the moment of inertia of the ring is bigger than the hollow sphere and disc and the solid sphere. So that is why if you release the 4 different shapes like ring, hollow sphere, disc and solid, which one moving faster? The solid sphere. Why? Because the angular speed for the solid sphere is bigger than the disc and hollow and the ring. Okay? Look, solid 2 kilogram ball. Okay? This is solid. It is radius 0.5 meter, standard height of 3 meter. The height is 3 meter. Okay? Rolls down incline, 20-degree slope. This is 20-degree slope. A solid disc, this is solid disc. And ring. How many shapes do we have? 3 shapes. Solid sphere, disc, ring. Okay? Ring. Start at the same height. Ball, the ring, and the disc have the same mass, same radius as the ball. Which of the 3 objects will win the race? So in this racing, which object, which ball win? And to the bottom of the roll without slipping? Absolutely the solid sphere. The solid sphere wins this racing. Why? Because the angular speed for the solid speed is bigger than the angular speed of the disc and the hollow sphere and the ring. Okay? And also mathematically you can prove it. Velocity for the solid is equal to 10 over 7 gh. Replace, final velocity is 6.48. This is 6.48 meter per second. This is velocity of the solid sphere. For the solid disc, it's equal to, velocity is equal to radical 4 over 3 gh, which is equal to 6.26. 6.26 meter per second. But for the ring is equal to gh, which is equal to 5.42 meter per second. Which one has more speed? The solid sphere. So that is why the solid sphere wins this racing. Okay? But in the case if this surface is a smooth surface, all shapes are landing or reaching the bottom of the incline with the same time at the same speed. Okay? Because for the free fall, V is equal to 2gh for all shapes. For what? All shapes. Okay? Now, look at this sample problem 2e. It's very easy. A solid ball with a mass 4.1 kilogram. This is mass. Radius, this is r. Okay? Start from rest at a height of V initial 0. With a height, this is height, 2 meter, and rolls down 30 degrees. This is angle. What is the translational speed of the ball when it leaves the incline? The ball is a solid ball. Because the ball is solid ball, V for solid ball is equal to, now I prove it, 10 over 7 GH. You are not required to prove it, okay? Just write down the equation of the final velocity of the solid ball and replace 10 over 7 times 9.81 times its height is 2 meters. So you don't need mass and the radius and the angle of the slope. V is equal to 5.29 meter per second. Okay? So I added another information, and for this question, in the case when the speed should be less than the speed of an object and they're going free fall, which one has more speed? The free fall acceleration has. When the object is falling through the air due to the gravity, has more speed than rolling on a surface, rough surface. Okay, because the free fall velocity is equal to 2gh for all shapes, so that is why its velocity is 6.26, bigger than on the incline. In a previous in a previous question, sample problem, at the bottom of the incline, what is the tire's angular speed? The tire's angular speed can be calculated by using this relation. Omega final is equal to V final over R. We didn't have V final, but we found it. We found it, which is equal to 5.29 divided by the radius was given. And finally, angular speed is equal to 105.8 rad per second. Okay? So I added this question. It's a very good question. So what is the total kinetic energy? Total kinetic energy is equal to 7 over 10 mv squared for what? For solid sphere. For what? For solid sphere. Is equal to 7 over 10. Mass was given 4.1. V we found it 5.29 is equal to 80.3 joule. Practice 2e. 1 kilogram bicycle tire, this is mass, radius, from rest, the initial 0, rolls down from the top of the hill that is 14.8 meter height. Height, we need height, 14.8 meter, okay? What is the translational speed of the tire when it reaches at the bottom of the hill? Assume that the tire is hooked with the moment of inertia 1. Okay, V is unknown. At the bottom of the incline, V final for the ring is equal to GH. G constant, H 14.8, V final is equal to 12 meter per second. So can you find the angular speed? Yes, of course. V final divided by radius. Okay. Question 2. A regulation basketball. The basketball is a hollow sphere. Diameter, you have to convert this diameter to radius divided by 2. Radius is equal to 12.5 centimeter. Convert to meter multiplied by 10 power negative 2, which is equal to 12.5 times 10 power negative 2 meter. Maybe approximated as a thin spherical shell at the shape of the basketball. How long would it take basketball starting from rest? What do you mean by starting from rest? V initial 0. How long does it take? It means that time is unknown. Very good question. Pay attention, please. Without slipping, 4 meter down an incline. The distance of the incline, 4 meter. This distance is 4 meter. Okay? And the angle is 30 degree. Okay? So the height does not given in this question with the horizontal. How long does it take? To find the time interval, in that case, V initial 0, V final, I don't know, we have to find it. But to find time, you have to use this equation. D is equal to what? The kinematic equation. V initial 0, V final, I don't know. Okay, we have to find time is delta T. Okay, so without V final, we cannot finding delta T. So that is why at first you have to try to find out what? V final. For the holosphere, V final is equal to what? Is equal to 6 over 5 GH. This is final velocity, V final, 6 over 5 GH, 9.81 times. Do we have height? No. The height is also not given. How can you determine height? According Pythagorean theorem is equal to D sine theta. D for sine 30 is equal to 2 meter. Height is equal to what? 2 meter. So V final is equal to what? Is equal to 4.8 meter per second. Replace into this equation. Now bring down this equation. D 4 meter, 1 over 2. V initial 0. V final we didn't have, but we found it. 4.8 times T unknown. Okay, this is cancelled. It becomes 2 is equal to 4.8 delta T. T is equal to 2 divided by 4.8 and is equal to, delta T. 4 is equal to half times 4.8 is equal to 2.4 delta T. So delta T is equal to what? Delta T is equal to 4 divided by 2 over 2.4. Delta T is equal to what? Delta T is equal to 1.6 second. Okay? Good question. Attention, please. Question 2 in practice 2E. Question 35. Look at question 30. A 35 kilogram bowling ball. This is mass, this is bowling ball. With the radius centimeter, start from rest. At the top of an incline, 3.5 meter height. Do we have height? Yes. 3.5 meter. Okay. Find translational speed of the bowling ball after it has rolled the bottom of the incline. V final is unknown. V final is equal to 10 over 7 GH. Just replace. It's too easy. Okay. Look at question 31. A solid 214 Newton ball with the radius R was given 0.2 meter. Okay. Rolls 6 meter down a ramp D 6 meter. Okay. As you can see in the picture, the distance of the incline is 6 meter. That is inclined at 37. Theta 37. Okay, this is 6 meter, 37 degree. Okay, with the horizontal, if the ball start from rest, this is the bowling ball start from rest, the initial 0. Okay. What is the angular speed of the ball at the bottom of the ramp? Angular speed is unknown. Angular speed is unknown. Be careful. How can you determine angular speed? Angular speed, final angular speed is equal to what? Is equal to V final over R. Do we have R? Yes. Do we have final velocity for the solid sphere? No. How can you determine V final for the solid sphere? Is equal to 10 over 7 GH. Do we have H? No, we don't have. How can you determine H? So you have to look the question. Do we have the distance of the incline? Yes, is given. And also the angle of the incline is given according Pythagorean theorem. H is equal to what? Is equal to D sine theta. H is equal to D sine theta. Replace 6 meter times sine 37. Height is equal to 3.5. Height is equal to what? Is equal to 3.6 meter. Now replace into this equation, V final is equal to what? 10 over 7 times 9.81 times 3.6. V final is equal to 7.1 meter per second. Okay, the question is not finished yet. We have to substitute into this equation to find omega final. V final we didn't have, but we found it. 7.1, R 0.2. Finally, the angular speed is equal to 35.5 rad per second. I hope you understood very well, and it is very easy, but please, you have to pay attention and you have to be very accurate to solving the question. At first, you have to write down the given values, and also you have to know what is unknown in the question. Okay, so you have to make a plan for every question. What is unknown in the question, you have to work with this unknown variable. Okay. Question 37. 0.02 meter diameter coin. This is diameter. You have to convert to radius divided by 2, which is equal to 0.01 meter. Coin rolls up 15 incline plane. So in that case, the coin is rolling up. It's not rolling down. It's the same thing, but instead of omega final becomes 0 at the top. The coin starts with the initial angular speed. Omega initial of the coin was given 45 rad per second. Rolls in a straight line. So there is some mistake in this question. I do apologize, because in this question the height of the incline is unknown. Determine the height of the incline. H is unknown. Okay. So how can you determine H? Because the initial omega initial is given. We cannot finding like that H d sine theta, because the distance is not given. So that is why we cannot use this relation. You have to think about another equation. Omega is equal to, V is equal to what? Because the coin is, it is shaped as a disc, 4/3 GH. Do we have V? No. But instead of V, we have omega. V is equal to what? Is equal to omega R. Omega 45. R was given 0.01. You have to convert to radius. Okay. V is equal to what? Is equal to 0.45 meter per second. So in that case, you have to multiply by the square. Sorry, multiply the square. V becomes a square and 4GH/3 the square with the radical cancel. Okay. H is equal to 4 times gravity, 3 times V square, 3 times 0.45 square. We didn't have V, but we found it because angular speed was given. There is a relation between linear speed and angular speed. 4 times 9.81 is equal to what? Is equal to 0.015. Okay? Is equal to 0.015. So in this way, you can find the height of the incline. Okay, guys? Now, look at question 41. It's about the ratio. Look at question 41. A solid sphere rolls. What is our shape? Is solid sphere. Rolls along horizontal surface at constant linear speed without slipping. Show that the rotational kinetic energy, okay, about the center of the sphere is 2/7 of its total kinetic energy. Is equal to 2/7 of what? It is total kinetic energy. Okay, so it means that the rotational kinetic is 2/7 of total kinetic energy. Now I'm going to prove this ratio. Okay, rotational kinetic, because our shape is solid sphere. For the solid sphere, I is equal to what? 2/5 mr square, and omega is equal to V/R square. Okay. Rotational kinetic energy is equal to 1/2 I omega square. But total is equal to 1/2 mv square plus 1/2 I omega square. 1/2 times, instead of I, write down what? 2/5 mr square times V square over R square. And in the denominator, write down 1/2 mv square plus 1/2 times rotational kinetic energy I is equal to 2/5 mr square times V square over R square. R square cancel, R square cancel. What does remain? 1/2 times 2/5 is equal to 1/5. Okay, because 2 with 2 cancel. mv square in the numerator. But in the denominator, we have 1/2 mv square plus 1/5 mv square. 2 with 2 cancel, 1/5 remain. Okay? 1/2 mv square is equal to 1/2 plus 1/5, 10, lowest common factor, 5, 2, is equal to 7/10. Is equal to 1/2 mv, 7/10 mv square. mv square with mv square cancel. According math basic, 1/2 times, you have to take this 7/10 in the denominator to the numerator. It becomes flips 10/7. 1 times 10, 10. 2 times 7, 14. Divided by 2, 10 divided by 5, sorry, there is some mistake here. Now, okay, 1 over 2 plus 1 over 5 is equal to 7 over 10, okay, mv squared cancel. 1 over 2 times 10 over 7, which is equal to 10 over 14. Okay, guys, divided by 5, this becomes, sorry, this is, yeah, 10 over 14. There is some mistake here, sorry. Now, let's try another time. 1 over 5 mv square, okay, 1 over 2 plus 1 over 5, lowest common factor. The lowest common factor is 10, okay, 10 divided by 2, 5, 10 divided by 5 is 2, 5 plus 2 is equal to 7 over 10, okay, so here becomes 7 over 10 mv square cancel with each other. What does remain? 1 over 5 times 10 over 7, sorry, yes, 1 times 10, 10, 5 times 7, 35, okay, both divided by 5, 5, 10 divided by 5, 2, 35 divided by 5 is 7, 2 over 7, the ratio of rotational kinetic energy to total kinetic energy. Okay? So this is the question of the section review. Inshallah, in the next lesson, we continue to solving all questions of the section review and the standardized test prep of the chapter 2. It is very important because they have very good questions. So thank you for listening. Inshallah, I will see you again as soon as possible, and keep up your best doing. Thanks for watching.